Okay, so I guess we'll start now. Now, it won't be too long. It'll be but yeah. Okay, so so I worked on a IRIS fellowship internship this summer, and I worked with Nick Smith and Jim Bowarski to develop what's called an xrootd implementation for fsspec. And for those of you that don't know, within the scikit HEP like ecosystem, there's a file system standard called fsspec that other tools within the ecosystem use to talk to different servers and data storage systems. And one of the biggest ones is Dask, right? Dask is it's a large data set analysis package that's used very commonly. And up until now, Dask and other tools that use fsspec would not be able to talk to xrootd enabled storage systems, right? And my project was to make it so that fsspec is compatible with xrootd storage systems. And I do have a little bit of a demo file to show how that works. Yeah, so I guess this this demo file, it's not available currently on the repo, but I think I am going to make a publicly available version. So okay, so we'll take from the top. In order to use this implementation, you have to have like Dask installed, fsspec installed, and all you have to do is pip install fsspec-xrootd in your environment, and that's all you got to do. It's up on PyPI. So starting from the top, it's just a simple text file example, right? Where on my machine, I have a local xrootd server running, and I have a text file. Well, I'm going to write a text file to the server, right? And you can run this code and it works just fine. All you have to do is fsspec.open and input the path to the server. And any path that starts with root refers to an xrootd server. So before, you wouldn't be able to do this with fsspec. If you just have a root file path here, it wouldn't do anything. But now it does work, and I guess this block of code does not output anything. But the next code where we read from that file that we just wrote does work. So let's run it. There we go. Right. So it's able to. So the implementation gives pretty much all of the standard features that fsspec requires, all the same standard features. So it lets you read the whole file with f.read. You can seek to any location, read a line, or read a specific number of characters from your starting position. And here, so we wrote some test data, and then we're reading that test data in the printout here. It also lets you do appending, and that's pretty straightforward. And it does all the basic file system stuff.
Scott, could I just interrupt just for a little tick? Your screen is actually the fonts are very small. I don't know
small?
if you zoom a little bit on it. Yeah.
Oh, I apologize.
Over video, it's kind of hard to see.
Yeah, let me I never actually thought about adjusting that. I don't know.
Browser by holding down Control and then Command.
Yeah.
There we go. Oh, all right.
Yeah, even one that's much better. Yeah.
Okay.
That's clear now. Thank you.
I apologize for that. I just never really noticed it before, but it is pretty small. But we're good. Okay. Thank you for pointing that out. Okay. Yep. So I've showed it works with all your basic file reading and writing stuff, but it also has some like server or like file system operations. Like we're able to search directories, get info about a certain file. And I just have some demonstrations of that. Like here, I'm going to populate my xrootd server with some sample files. Let's do that real quick. There we go. And yeah, here. So here we're going to list some. Well, we're gonna list the files at the demo directory. And you can choose to have more or less information about them. I know this looks like a mess, but the first output is just a list of everything at that directory. And the second is a detailed list where it gives you everything. Like all the stats about the file. And one of the most useful features is cat ranges, where you can read multiple data sets from multiple files. And that's what we have going on here. It took a little, it took a little longer to make that work than I expected to, but it's all good. And of course, it has both fsspec-xrootd has both asynchronous and synchronous functionality, right? So when you create your file system object using the standard fsspec function here, you just specify that you want it to be asynchronous. It's synchronous by default, but you set asynchronous true, and you can run things asynchronously, right? And it handles all that just fine. Here's a simple example running two things concurrently. And that's the last thing, and this is the most important part, is that now Dask is able to read from xrootd servers, right? So you have your standard, read CSV in Dask data frame, and now you can just give it the URL of your xrootd server. And I have a CSV file in my server currently, and it'll read that CSV file. So I mean, that's it for the demo, but it's pretty straightforward. Right now, if you want to access data on an xrootd storage system, all you have to do is give Dask or fsspec your the server URL, and that's it. I mean, some future. Well, I guess this project is. So the core of this project is done. I did finish that this summer, but some future improvements we want to make is to make it so that not only can Dask read from xrootd servers with the simple URL, but also read root files, .root files with just a simple URL as well. And to make that happen, it involves a Dask uproot, implementation. And something that my mentor had been working on is an uproot fsspec source, right, to make that all work together. That is not complete yet, but that is future work that might be coming soon. But for now, this fsspec-xrootd implementation is out, it's working, it's ready to go on PyPI.
Thank you
so
so much.
I think that's it.
Yeah, that's really nice to see that development, given the relatively ubiquitous nature of xrootd interfaces on this kind of storage systems that we run in HEP.